Next talk is Sarah Antier from Observatoire de la Côte d'Azur, and she will give a talk on the time domain with the CFHT.
So thank you for the opportunity to present this time domain. Of course, I won't talk about LISA. Okay. So I will not talk about LISA sources, but more about time domain. And here is about, just to remind, the type of source that are time domain for us, taking, for example, the example of LSST. So when we have extreme AGN variability, so very fast time domain transient, supernova, some kind of variable star, accreting by damn small bodies. And here my talk is more focused about exploding transient with high energy and connected to multi-messenger experiments. So for me, my talk was a bit very pragmatic. So how to find like counterparts of ground gravitational wave detector or neutrino or CTA sources or everything, right? But time domain. So for me, there is 1, 2, and 3 approach. The first one is you have a trigger from someone, an alert, and you point a CFH for this. Okay, this is what I call the follow-up. Number 2 is to scan a part of the sky and to find complementary data with other survey, or find yourself, CFH by themselves, a trigger that is connected to exploding transient or something else. This is strategy number 2. Strategy number 3 is to not point CFH, but query the database, because maybe it have also a portion of the sky for which there have been an exploding event. So I will go to, is my 8 minutes left, to these 3 approach. So first one is the follow-up. Why we need CFH for a follow-up? Because as you know, there are many telescopes. They can do repointing. In France, we have Colibri, etc., etc. So why? Because CFH, in fact, is located in a very interesting area, and it can observe both part of the north, part of the south, and it is where there is no other facility except the telescopes in Hawaii, like Atlas. But between Atlas, which is a 50 centimeter telescope, Pan-STARRS, and CFH, there is a scale in terms of magnitude to reach in a very short delay. So this is why it is a plus. Second one is with MegaCam, we can operate some kind of transient that are not well localized, which means that the localization is within arc minutes or even within a degree. So that's why MegaCam can image and find the counterpart directly. So this is very positive. Of course, the last advantage is deepness. So it's very suitable, for example, for neutrino alert, because neutrino alert are not that localized, like not in arcseconds, or SVOM alert, or X-ray alert from Einstein probe. So all of that is positive. What is not positive for the moment is that it's true that the way to ask alert, as Nadine said at the beginning, is not like straight away, you know. And furthermore, is not like when you have a sources, you do this sources and then go to another target. Is quite difficult over the moment, but I hope that for the survey time it will be more smooth. Also, when you pick up about multi-messenger, it's true that you can allocate a large time, but you don't know what you get. So it's good to maybe like make sure, okay, you have a large time if you have a very rare event, an opportunistic event, but good to redirect this time to another program. Okay, so number 2 is this kind of survey that you do. So a la LSST, a la Vera Rubin, a la Zwicky Transient Facilities. And for this, what are the positive is that not only you will survey something that is interesting for high energy sources, but also fill all your program with what I showed before, AGN, supernova, small bodies, etc. If CFH makes some collaboration with some brokers, a la LSST, I think about Think, which is a front broker, but there are other available. So now the backside is that it's true that the field of megacap is not so large, you cannot, it's only dozens of degrees per night. So will it be sufficient to have this rare event? Will it be sufficient to be a bit in competition with other more widely surveyed or 20 degrees square? This is the question. However, as I said, it drives multiple science. The other advantage for this is maybe to adjust with the observing run, for example, of LSST or ZTF, so that it observes the same field during the night. So we can organize double joint scheduling. Okay, the number 3 is archival analysis, because maybe with other survey or the other from Megacam, they have observed a region that was interesting. And to query, but not query after 1 year. Query now, maybe CFH has observed something for another, program, but maybe there is a source that we need for time domain in this program. So the idea here, the challenge is to have quickly access to the database. So I hope I have few minutes. Now the time allocation, so very briefly, I think for the TO strategy, it will be about 10.9 per year for all the follow-up of the sources of the trigger that I talk about. For the survey, it should be, 59 per year, I think should be fine. And for archival approach by 0 is free. The instrument that we can use is, of course, Megacam. That is true that if we find collaborators that would like to use a small IFU, it solves the problem. So it's not that we place the RFU, but someone has an RFU. It solves the problem to have characterization of the fast transients, which is a big challenge right now in time domain community. So finally, I think is not only the instrument, but how to collaborate, because this requires a lot of online analysis, as you have understand, to produce, especially for the broker, measurement straight away. And so the idea is how the community, the CFH community of collaborators, sorry, I talk about France because I'm French, but how the community can do this data reduction. I know that they have been initiated with colleagues on Megacam, so how to do this collaboration to provide immediately the photometric points. So thank you. I don't know if I was too fast or not, but if you have questions, I am happy. And I'm happy to give feedback also to me on my vision.
Thank you, Sarah. So questions? I do have one. So any filters of preference? Because with Megacam, what will be the best for you to be in the U band, in the I band? Is there any filter combination that will be more appropriate?
So to understand the process of the emission of the ejecta, usually we need different filters to characterize the source. There is two approaches. There is one way to detect something with CFH, which will be any filters. Usually the community takes the air band, but it's not obvious. But then it's good to have multiple filters.
Mm-hmm. And
which between the different process and different fast transients.
And yes, depending on the type of events it is, you need to react faster or less fast. So basically, what's the fastest need that you have for this?
But the problem is that if you want to make a spectroscopy, for example, just after, there is no much spectrometer in the world. So it's good that if you're making like a survey with, John Sky with DCAM or LSST or ZTF, it's good to operate the same night. I think it's more about like you make a request, it is validated or not, depending on how much important is the program ongoing. And then, you like this kind of priority. And then you say, okay, no, I cannot, So I don't have to say it's good to overload, let's say, to propose more target. And if it cannot be observed this night, it's fine. But at least it is already sent. For AGN and supernova, of course, we are not, pumped like hours, right? So it's more about days for the other one. So reaction.
Yes, and questions.
Hi, it's Evelyn Adesian speaking. Can you tell more about why you need IFU?
We need IFU because it's a way to have a small, low-resolution spectra to characterize the source. Because what you can do is either to characterize with a photometry. So for that, you need a lot of resources to have a light curve. Either you characterize like this, and for the moment, according to myself, there is no much from characterization of the sources, right?
There are questions? No, not in line. Okay. Thank you, Sarah, again.